All right, final review, Unit 12. All right, so formulas, just real quickly. Probability of A and B is probability of A times probability of B. A or B, this is when you got to take out the middleman. Okay, so you add these two together, but you have to subtract thing from the first, A times B. This is when you have, this overlap, which counts as part of this one and part of this one. So if you just added A and B, you'd be counting this part twice. So that's why we have to subtract it out. Remember, this means A given B. All right. So first off, we talked about if it's independent, then it's just the same thing as the probability of A. If it's dependent, then it's the probability of A times B divided by the probability of B. Okay. And vice versa. If it was B given A, you would just put probability of A on the bottom. Permutation, the correct formula is this. But as long as you just go to use the math key and go to NPR, you're fine. Remember, this is your N and that's your R. And in combination, here's the technical formula. It's the same thing, except it has this extra R on the bottom. But again, if you just put in NCR from the calculator, you're good to go. Okay. First off, we're going to talk about the law way, because if you're asked how to make a tree diagram, this is how you do it. So first off, you can get heads or tails. Then you're going to spin a spinner with 4 colors: red, green, blue, and yellow. And if you get tails, you get red, green, blue, or yellow. This would be B. Okay, there's your tree diagram. And then you just count up. 1, 2, 3, 4, 5, 6, 7, 8. 8 possibilities. But remember, another way to do that is there's 2 possibilities here, there's 4 here. You simply do the counting method. 2 times 4 is 8. Now it says, what are the elements? Oh, it doesn't say what the element. Oh, it does say, sorry, list the sample space. So you get heads red, heads green, heads blue, and heads yellow. Then you can get tail red, tail green, tail blue, tail yellow. And those are your possible choices, all 8 of them. Okay, I don't know what happened here, but it's missing a few of them. This should be a 5.8 over 7, and this should be a 10 over 8. Now, some people look at that 100 and think that's good, but that's only if it was 100%. 100%? That would be an appropriate answer. But this is the number 100. And remember, we have to have between 0 and 1 to be valid. 100 is way above 1. 0.333, perfectly valid. It's between 0 and 1. 75% is 0.75. Okay? So another way to think about this is between 0 and 100%. 5.8 is less than 7, so we're good to go. 10 over 8 is actually 1.25, so that's a no. If the numerator is bigger than the denominator, it's a no. Okay, fundamental counting principle again. We talked about this up here with the head, tails, red, green, blue, yellow. How many elements are in the sample space? It's not asking you to list out the elements, just how many. Well, if you have 5 children, 1, 2, 3, 4, 5, and you have 2 choices, that equals 32 possible combinations of children. A wardrobe has 4 shirts, 3 pairs of jeans, and 5 pairs of shoes. You simply do 4 times 3 times 5, and that is 60 possible outfits. Okay. Remember, you could do a tree diagram, but it would be very long and messy. All right. Best description for each of the following: 1 to 20. Okay. There's 20 numbers, obviously. The even numbers, well, you can list them out, 2, 4, and so forth, but you know that's basically half the numbers, 10 out of 20. Half the numbers are odd, half the numbers are even. That's equally likely. A factor of 12, well, that's numbers that go into 12, like 1, 2, 3, 4, 6, and 12. Count them up, 1, 2, 3, 4, 5, 6. So that's 6 out of 20. It's less than half, so it's unlikely. A number greater than 21, that's impossible. It only goes to 20. Okay, Venn diagram. So you just make 2 circles. A here, B here, label it. Okay, and then it says the probability of A and B. That's in the middle. That's 0.12 in the middle. Sorry. Yeah, that was given. Okay, so 0.12 in the middle, and it says 0.21 for A. Sorry, I'm in the wrong place. 0.21 is A, and 0.35 is B. Now remember, they both contain that 12, so you actually need to do 0.21 minus 0.12 to find out this part of A, because these two together make 0.21. And then 0.35 minus 0.12, well, that gives you 0.23. And again, those together make 0.35. Now, the probability of A or B, whoops, I don't know what happened there. Okay, somehow that page got deleted. Hold on. Ooh, that was scary. All right, sorry about that. Technical difficulties. Okay, remember, probability of A or B. Well, since they overlap, remember, we need to do 0.21 plus 0.35 and then subtract out the overlap to get 0.44. And the probability of A, but not B, so we want to look here at A, right? But we don't want anything to do with B. So since that 0.12 is A, but also B, we only want that part. The part of the circle A that does not have any B in it. Now it says shade, not A. Okay. Well, everything out here is not A. Oh, I lost my 0.23 somehow. And this in here is not A. And it's not independent, and I'll prove why. Because 0.21 times 0.35 equals 0.0735. And that's not the 0.12. Which is why, since it's dependent, we had to do this formula, because there is the overlap. Okay, looking over here, and this should be soccer. Sorry about that. All right, so set A is soccer and B is baseball. So that's soccer and that's baseball, if it helps to lay it out there. Number of total students. Okay, well, the number of total students, you need to add up 10 plus plus the 25 plus the 13 plus, don't miss these out here, 9. That's 57 students. Okay, there's 10 that just play soccer, there's 13 that just play baseball, and there's 25 that play both. Now, the number of students who play both, well, that's 25 I just said. Number of students playing soccer or baseball. Okay, so that number, you gotta be careful. Again, if you add up the ones that are playing soccer or baseball, hold on. Remember, there's 35 playing soccer, and there's 38 playing baseball. You cannot add just those two numbers because these people would be counted twice. So if you're trying to figure out who plays one or the other, you have two choices. You can add these two and subtract 25, or just add these three, and you get 48. Number of ones playing soccer but not baseball, well, that would be 10. Okay, so soccer but not baseball. One's playing either sport, not playing either sport. Okay, that's careful there. That's at 9 up in the corner. Shade the region of students not in soccer. Well, that would be anybody out here, obviously, because that's the not, and anyone over here. But you can't include that middle because they are playing soccer. How can you determine if two events are independent? And that's pretty much from the formula page. But we test it. If the probability of A times the probability of B is equal probably A times B. Also, if the probability of A given B equals the probability of A, or if it's reversed, I referred to this on the first page, if the probability of B given A is equal to the probability of B. That's mathematically how you know they're independent. Okay, A and B are independent. B is 0.7, A and B is 0.35. We're trying to find this. Remember, these two multiplied give you this. So to find backwards, we do 0.35 divided by 0.7, and we get 0.5. Now here, we have A and B. We're simply going to multiply those and get 0.12. All right. Number 10. So remember, a deck of cards has 52 cards, 4 suits, 13 each. So probability of a jack, well, there's 4 jacks in a deck of cards, or there's 1 in each suit. Those are the same, either answer is fine. The probability of a red ace, well, there's hearts and diamonds, so there's 2 out of 52, which reduces to 1 out of 26. Either answer is fine. You don't have to reduce. Probability of a 7, well, they're just like the jack, there's 4 of them. So, jack, 7, 3, king, same thing. Probability of a red card, which there's 26 red cards, or an 8. Now, remember, you can't just add those two together because there are 2 red 8s. So you have to subtract those out. And that gives you 28 out of 52, or 7 over 13. A black card and a queen. Okay. and remember, we're replacing them, okay? So the odds of getting a black card is 26 over 52. Chance of getting a queen are 4 out of 52. The chance of getting one followed by the other, you have to multiply, which is 104 over 2704. Now, how do you know we're not just asking, why is it not just 2 out of 52, like B, red ace, because we would have said a black queen. But we're talking about a black card and a queen after it. Okay, F, a heart given a 4. Okay, so this is your A, this is your B. Okay, so remember, for A given B, it's just the probability of A. So therefore, the probability of a heart is 13 out of 52, or 1 out of 4. Jack, given it's a black card. So this is our A, this is our B. So again, probability of A given B is just the probability of A, and that's 4 out of 52, or 1 out of 13. Okay, for some reason this got cut off. Set A is the 4 of hearts and the 5 of diamonds. And set B is red cards. I don't know why that got cut off, I apologize. Is set A, this is a subset of B. In other words, is the 4 of hearts and the 5 of diamonds in the category of red cards? Yes, it is. Okay, 11. What's the probability of a cannon? Okay, well, probability of a cannon, we're going this way, is 153 out of 254. B, what's the probability of a Xerox and large? So we're looking for Xerox and large out of, again, 254 total. What's the probability of a small and a cannon? That's right here, 99 out of, again, the total 254. Now, this is where it's going to change up a little bit. What's the probability of a cannon given large? So large means we're starting down here, this way, okay? And that means 132 is going to be our denominator. And that's how you read it. It's given large. So since large is basically the first thing, I know it says cannon then large, but given means that comes first. That's going to be our denominator. And then we just go to cannon, and that's our numerator. Small given Xerox. So if we're given Xerox, we're going this way. That makes 101 our denominator. And then small, 23. And then large or Xerox, well, large is 132. Xerox is 101. And then you got to remember to take out the overlap of large Xerox. And that gives us 155 over 204. So think about it. Watch this. Okay, so what's probably a large? So large, that didn't work. Probably a large goes this way. And then probability of Xerox goes this way. There's your 101 and 132, but notice, you can't read it, the 78 is in both categories, so that's why we have to subtract it out. Okay, what's the difference between permutation and combination? Well, for permutation, order is important. Okay, so it matters here. And for combination, it does not. So order is not important for combination. Number 13a, find 4 factorial. So you're going to go to your calculator, put the number 4, go to your math key, over, and then number 4 is your factorial. You can either arrow down or just hit number 4. And so that's 24, which is the same thing as 4 times 3 times 2 times 1. Entering combination, very similar. You're going to hit the first number, go to the math key, over to PRB. Now remember, it says combination, or it has a C there, so we're going to go to number 3. Then we hit the number 2, and that's 21. And C, we're doing a permutation, so similar idea. You put the first number in, which was a 6. Math key, over to PRB. But this time we're going to number 2 and PR, and that gives us 120. And we'll do another combination, 9, 6, so 9, math, PRB, combinations 3. Then we have our second number 6, hit enter, and that's 84. So there's 84 different choices. Okay, how many different lock combinations are possible if the first 2 digits are 2, 3? Well, there's 4 slots left. It's kind of small, so there's 4 slots left. It doesn't say anything about repetition. There's no limit on that. So basically there's 10 digits here, 0 to 9, 10 here, 10 here, and 10 here. So that's 10 to the 4th power, or 10,000. So basically 100, 1,000, 10,000. And number 15 here, we have 25 students in the class, and we're putting them in groups of 5. Nowhere in here does it say there's any rank or order to these groups, so that means we're doing a combination. Now, if it said that the 5 groups had assignments, like slot 1, 2, 3, 4, 5, or leadership positions, it would be a permutation. But otherwise, it's just 25, math, PRB. We're doing combinations, so that's 3. Like I've said before, you can also arrow down and hit enter. It's quicker just to hit the number. Hit 5, and there you go, 53,130. Let me just double check, make sure I got it right. Yep. That's how many possible groups there are. Okay, almost done. 16. There are 6 notes to be played on an instrument. Each note gives off a unique sound. How many different 3-note sounds can be played if no note can be used more than once? Okay. So if no more than once, that means order is important. Which means permutation. So quite simply, we just going to do a permutation, 6 notes choosing 3. So just a reminder here. Board's off. Let's do this. So we turn this on. It's not going to work. Let's try it this way. Okay. So remember, we just hit the 6. Then we go to math, over to PRB. We're doing permutation, and then we just hit 3. And there's our answer, 120 sounds. Okay, you're taking a test with 10 multiple choice questions. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 5 each. 5 choices each. And 3 true false. True false, true false, true false. What is how many different combinations of choices are there. That's a lot. Instead of typing this all in, remember, we just did 5 to the 10th, and that's 2 to the 3rd. If you just type that in, okay, much easier, 5 to the 10th times 2 to the 3rd, or if you just know that's 8. That didn't work right. Sorry about that. Forgot to hit over. Times 2 to the 3rd, which is 8. And there's your answer. 78,125,000 ways, or combos, or whatever. All right. Get rid of those. There are 11 performers. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. But one of them insists on being first, and one insists on being last. How many different ways are there to schedule the appearances? So we know somebody's got to be first. Okay, so and one's got to be last. That leaves 9 people. So this is just 9, 8, 7, 6, 5, 4, 3, 2, 1. Now, if you notice, this right here is just 9 factorial. And the ones don't really matter. So if we type in 9 factorial, again, go to our calculator, hit 9, go to the math, over to PRB. Number 4 is the factorial, and there's our answer. 362,880 ways of ordering the people. And last but not least, it says there's 123 families asked. So that's our total down here for sure. Now, it says about owning a Honda or a Ford. So we're going to put Honda on one and Ford on the other. And then this is going to be people that don't have one, and this is people that don't have a Ford. Okay. It says 65 families own a Honda. So that's right there. 21 families own both. Which means 44 did not. Simple subtraction, 65 minus 21. It also says there are 30 families that owned neither. Not. So 44 plus 30 is 74. 123 minus 74 is 49. 49 minus 21 is 28. And 28 plus 30 is 58. And there's a lot of different words you can go about that. Now, how many families did not own a Ford? So, not, that's Honda, sorry. How many families did not own a Ford? That's 74. Right there. Sorry, I had it backwards on my original key. What's probably of a Ford given a Honda? So given a Honda means 65 is going to be our denominator because we go down the column. And then Ford in that column is 21. What's probably of a Honda just overall? Well, there's 65 Hondas out of 123 families. And what's probably of a not Honda given not Ford? So not Ford means we're going here, which means our bottom number is 74. And then not Honda is 44 out of that number. Wait, sorry, my bad. It said not Honda. So not Honda is right here. So that's 30. Sorry about that. Again, my thing was backwards. So again, if you look at it this way, I'm given not Ford, which means I'm looking this way. Okay, and 74 is my denominator. And not Honda is right here. There's my numerator. That's it.